As I covered in the last video, a DOE is an experimental setup that varies multiple factors over the course of the experiment. It does this by providing a list of different combinations of settings, or levels, for each factor. Now, each combination is called a treatment condition. And I only talked about the full factorial and a very simple example at that, a full factorial with just two factors. But there are many different structures for DOEs, and there's also many different uses for DOEs, to suit whatever your particular needs are. Now, I'll run through some of the most common structures and uses so you can get a better sense of what's out there and what's available. Certainly not all of them, but, a good handful. So, the full factorial is the base structure. It's when you run the full set of combination of factors. Factorial designs, including the full factorial, have two levels for each factor. In the last video, I just referred to the two bake time levels as shorter time and longer time. The factor is bake time, and it had those two levels. If we were actually running that experiment, we'd give them specific values like 10 minutes and 14 minutes. Because basically when you run the experiment, you have to set them at something. Now, for factorial DOEs, we can have many more than just two factors. And as you add more factors, more factorial structures become available. And those are the fractional factorial experiments, right? I talked about the full factorial, but you can have fractional factorials. And as the name suggests, they're similar to the full factorial, but only need to run a fraction of the treatment conditions. And remember, a treatment condition is a specific combination of levels for each factor. And in the last video, higher temperature, lower time was a treatment condition, right? So it's all your factors set at one thing, each one, treatment condition. The fractional factorials are named by the fraction of the treatment conditions within them, right? So a half fractional would have half the treatment conditions. A quarter fractional would have a quarter of the treatment conditions. All the fractional factorials are in a factor of 1/2, right? So it's half, quarter, eighth, a 16th, etc. And again, you have to be running more and more factors to be able to get to those higher and higher fractionings, because you wouldn't run an eighth fractional on only a 3-factor experiment. Right? You'd need more factors than that. If you want to move beyond just the two levels for each factor, one option is to go with response surface methodology, or RSM, you might see it seen. Response surface designs, unlike factorial designs, allow for having more than two levels for each factor. Generally speaking, we don't use experimental designs that have more than two levels for each factor for experiments with lots of factors, right? Because the number of treatment conditions will start growing exponentially, right? If you have 8 factors, each with 7 levels, that's just a lot. So we typically use response surface designs when we've narrowed down to, say, somewhere between 2 and 4 factors that we're looking to test. And, really important factors. The structure of the response surface design allows us to model curvature, which allows us to graphically represent the impact of any two factors at a time on the response. And so that ends up looking like a surface, right? Hence, response surface designs. The last structure I'll discuss is mixture designs. They're akin to factorial designs, but are made to experiment on mixtures. So for example, back in the cookie example in that last video, if we wanted to run an experiment on the sugar and flour, we might run a mixture experiment. And that's because mixing the sugar and flour together is different proportions of ingredients, right? Mixture experiments account for things like ingredients. When adding one thing de facto reduces another, right? In most recipes, and certainly in baking, it's that ratio of ingredients that's important. So adding more sugar is sort of like the same as reducing all of the other ingredients by a little, right? So again, mixture designs account for that. Side note, mixture designs are not the same thing as mixed level designs. Mixed level designs are like full factorials, but with various number of levels per factor, including more than 2. Mixed level designs are cumbersome and can be a challenge to analyze, so you might want to avoid them. And honestly, if you have a good approach to experimentation, they're rarely needed. So That's a good representation of the common DOE structures. Now let's move on to some common ways of using the DOEs. And when I say ways of using them, it's really about what knowledge you're trying to gain from the experimentation that you are doing, right? And product development is gaining knowledge. So for example, one use for experiments is screening experiments. So in screening experiments, we try to screen the factors to filter out which factors are important from those that aren't. Now, these tend to be hyper-efficient designs that have sacrificed in-depth knowledge for efficiency, right? The knowledge needed to be gained is very surface, like which factors are relevant and which aren't. That's it. Then there are modeling experiments. They're intended to establish a mathematical model, aka a transfer function, for a particular function of the product or process. So we'd be able to have an equation for making a great cookie, for example. Or a horrible cookie if you'd prefer to make that, or anything in between, but the equation would be able to govern all of that. Then there's robust design experiments, and these are actually a pairing of screening experiments on noise factors with either a factorial design or a surface response design, or potentially others as well. And we're trying to methodically remove variation from the product's performance. Now, I bring up robust design for two reasons. First, it's powerful and awesome, and it's on the path to immortality of product development. Second, it's an example of how you can combine experimental structures to reach yet another tier of awesomeness, right? So this is like multiple tiers above that one factor at a time testing. So that's it for DOE structures and uses. Again, there's a lot more than I just covered there, but I couldn't possibly fit them all into one video, but that should give you a good feel of what's out there. Thanks.